Morning. We did it. Got to 100 degrees yesterday. It was hot. It's going to be, the forecast is about another 100-degree day, but it'll only be in the high 90s the day after tomorrow, and then down into mid 80s next week. So, yes, it's hot. So, but here we're ready. We have this whole week for review. I'm going to show you some of the resources I'm starting to set up. What you need to be doing is do your best to finish up on the homework, but also start switching over to really focusing on the review portion. And that will help you. If you were struggling with some of the homework, going to the review will help you with the test, and it should help you also with any homework that's left over. And actually what I do, I update the scores, and as long as you get 70% or above on the homework, you'll get the full credit. So don't worry about one or two that you might be struggling on. As long as you get to that 70%, you'll be good as far as points. And then focus on well, let me show you. Let's go ahead and get to it. So here's exam 3 stuff. Remember, we don't have to go back to exam 1 or 2. That's not going to be on here. Although some of those concepts, probability still is. So, but we'll go through these. In the review resources, I've updated this, and this is where I will be putting all the stuff. So as I do individual videos, I'll come here. So I've now got a highlighted version of the exam because yesterday late afternoon I received a copy of the final exam, exam 3. So I know what's going to be on it. I compared, and these guys do a really good job of having what's on the review is what you need to know to be on, is going to be on the exam. Some questions are very similar as far as the setup. Sometimes they call it different things, but you'll see working through this is going to, I counted at least 5 where if you just change the wording, what they were calling it, you'd actually have the test problem. So there's some very, very close in here, and others that the concepts are so close. So if you've got all that, and then I posted a picture of the cover page so you see the exam questions or instructions. It'll be 20 questions, which is a little bit more than we usually do because they've got extra time. In a way, that's better because that makes each one worth not as much. So if you miss one, it's not as big a deal as like last time. There was ones that were like 8 points. If you missed one of those, that's almost a whole grade letter, right? So most of these, you got, let's see, you've got 12 short answers instead of 7. Some are multiple choice, some are the short answer type. And then there are 8. They didn't really say, or maybe they did. But since there's a total of 20, the 12 short answer multiple choice, 8 that are show your work type stuff. So we'll work through all of that. A lot of this stuff will be using the calculator. There is on the exam, they will provide the table of values for standard normal, but I opted to show you only how to use the calculator. But if you want to learn how to use the table, that will be provided. So it does provide some things, but again, depending upon what area you're looking for, there's about 3 or 4 different ways you have to go about using that table. Whereas if you get using the calculator with that technology, it will work all the time. Especially if you use that graphing part, use that one equation and graph with that, you'll see the graph and you'll get your answer as well, very accurately. So those are where I sort of transform a little bit. I don't believe in grading methods. So if you have a method that works and gets you the answer consistently, that's what I want you to have. So we'll focus on doing that. And I've started, because I had a couple other things to do, but this morning I started making up, copying over from the other PowerPoints, sort of just a review portion of what we need. So I think I got through the first 4 sections. I'm doing this, and I'll keep adding to it. So what I do is I go back to my old lecture PowerPoints, and I say, okay, this is the one that has the formula. So I don't go through the whole lesson. You could still go back and do that, but I'm trying to do the short. This was from the lesson, because if you see it, maybe that triggers the whole lecture or the concept. So we'll do that, and what I'm going to do is I'll do a few of these, and then we'll work some of the questions from the highlighted review. So this is the same review. I didn't change anything except put a few highlightings. There's 23 questions in here that are highlighted. There's 20 on the exam, so it's pretty close. You don't have to work anymore. Like threes, it's not that this is a bad one to work, but I just said, what are the minimum numbers so that I could get everybody, if you work at least those, you will have all the content for the exam. So at least work those, and then come back and do these. It's not that these aren't bad. There's one on the median down below. We don't have that. But again, if you focus at least on the highlighting, you'll have an overview of the test. And then you can come back and work some of the others, and you'll see, oh, this is similar, so it's an extra practice. Okay, so all of these, we'll work through a few of these. I will at some point this week make up videos. So you see there's, some of these were built to kind of get you to understand how to create them. Again, they're not bad to work, but I kind of went with ones that were, get you to the concept, and if you can do this, you'll be fine with the exam type thing. So cutting it down a little bit, but some of them, there's, like you can see, there's several in a row. So you should work at least through those. All the answers are here. They don't have solutions or methods, but just the answers to check. And again, I'll be working to get those. And part of the thing that I struggled with a little bit was we have multiple methods for some of these things, right? And so if you just see a question, sometimes I was even having, which one? Oh, I could do it this way, or I could do it that way. I'll get the same answer. So part of this is you'll look at a question that might be from a particular section, but you could use something from a previous section or something. So it'll do a good job of cementing everything. Okay, so let's go ahead and start in. First, are there any questions or comments or concerns or anything at all? Okay, let me know. And so we'll work a little bit, and then we'll kind of get through these, I think about 4 sections. By Wednesday, I'll have the rest of the sections. We'll make sure Friday is going to be really a completely open work day. You can choose to do it wherever you want, but if you come here, we can give you some assistance on any questions. If you have questions, come in Friday. We'll make sure they get answered. Next week, we don't have any office hours or any meetings. We just have the final exam, or exam 3, next Thursday night, right? 7:10 p.m. We'll still be in the same place, which is, at least we'll have something that's normal. Everything else changes. Okay. So, and again, this is a really good opportunity to just focus on this stuff and do really well on this exam. Okay. So let's go ahead and go in here. We've got a couple questions we'll take a look at on conditional probability, but I wanted to kind of go over this because I'll just tell you, there is one question that presents you with a table similar to this, but there is no practice problems in the review like this. So there was one question that was not exactly there, but it kind of works like this. And so I'm going to go to this because this builds up our understanding of conditional probability. We have a table, we can do it. We're also going to build a tree diagram, and then we'll also look at the symbols. So there's really 3 different ways to do this. And actually, you could also use a Venn diagram, right? If you do the right overlappings and stuff. So there's 4 different ways that we can all arrive at sort of the same answer. So this was, I took out the question because I just want to focus on the portions of it. But it was, there was an advertisement sent out to gamers, a game club, and they wanted to see who would purchase it or not purchase it, whether they saw the ad or didn't see the ad. And so that's the breakdown we have here. Okay. One of the things you need to do, now, a lot of times they provide us with the totals, but if they don't, and sometimes they don't even put a box for the total, the thing we want to do is we want to get those totals. So 20 plus 70 gives us 90. 80 plus 630 gives us 710. 20 plus 80 gives us 100. And 70 plus 630 is going to give us 700. And then the total of the totals, that goes here, 710 plus 90, or 100 plus 70, whichever way, they both have to add to the same number. There's our 800. So we can use those. And again, we could do conditional probabilities is where we're starting. Remember, back on test 2, we did some things with just general probabilities. But this test starts with just conditional probabilities. What is a conditional probability? There is a condition that we know. So we have some sort of advanced knowledge. We know something either happened or will happen. We know the future. It's kind of cool. So conditional probability, we know something either happened or will happen, depending upon what we're doing. And so the thing we're going to do is if we know that we're only dealing with the people who purchase the game, then what we do is we focus just on these numbers here. And we'll ignore all the other numbers. So this is maybe the probability of, let's see, we know A happened, right? So that's given that A happened. We might want to see what was the probability that they bought the game given that they saw the ad. So that's a conditional probability. We're going to look at just one thing. And there's actually 4 different conditions we could have had. We could have they purchased the game was what one condition. They didn't purchase the game. That's another condition we could look at. They saw the ad. That could be one condition. They didn't see the ad. That's another condition. So there's 4 different conditionals. And then we're trying to find out the probability of the other thing happening. Okay, so purchase a game. So something like that. What I wanted to do is here, I've got it open and start using some, so we can, when we get to the formula, we can see how the table relates. We never did this, and I thought, I should have done this. So what is this square here? Well, it's an intersection of 2 things, right? The number here, that 20, is the intersection of A and B. So it's the number in the intersection of A and B. And you'll see, because that's going to relate to our formulas. And we talked about it, but you can kind of see it there. That 20 is an intersection. But now we'll just label it out what it's the intersection of. What is this the intersection of? This is the number in the intersection between A and not B. And sometimes, watch that little not, that little apostrophe, because that means not B. So sometimes those are harder to see. And then this little guy down here is the intersection of not A and B. So it's the number in not A intersect B. And this one is the number in, see, how do I do that? Not A intersect not B. Okay. And you can see how, and then the totals are the number in B, the number in not B, the number in A, number in not A, and then all of them together. The total sort of universe, right? So that's going to help us with coming up with the formulas. So let's just look through here. How would we come up with the probability of A given B? So B has happened. Let me erase up here. There we go. B has happened, so which row or column are we looking at? Are we looking at a row or a column? B has happened. Row or a column? A column, good. The column that says they saw the ad, because that is B. That is B happening. The other one's B not happening. So whenever we're given B, we know this happened. So this is all we're looking at. Does that make sense? So those, we ignore all the other numbers. That's cover them up or something. That was the hardest thing sometimes, because then you start trying to use those other numbers. They don't exist. Okay, they don't exist because we know B, only B happened. We know that. So we're in this world. And so we could say and so the total is 100. That looks like 160. It should be 100. Should be 100. Okay, so now we're going to tie together how would we calculate this probability. Remember, probability is just the number of observed items, the number in the event, divided by the total numbers. But be careful, it's not going to be this total. It's not going to be the 800, right? Because that doesn't exist. Because we had advanced knowledge, it's going to be the number in A intersect B, which is this square here, this piece of data, divided by the number in B. The number in B is the total, because we know it happened. Not B did not happen. So nothing else happened. So notice how these all, and you could kind of see, oh yeah, it's these two numbers. So it's 20 divided by 100. And that's conditional probability. So 0.20, which is equal to 20%. Okay, makes sense? And again, we'll do some others with probabilities, but sometimes they give us stuff in terms of the symbols. Sometimes they give it to us in terms of probabilities. So we've got to be able to, however they give us the question, we got to be able to do these. And I already told you there'll be one that they give you the table. So from the table, you got to be able to pick those. You don't necessarily need to use the symbols when we have the table. You say, okay, it's this one, it's this number, and this number. Hey, we're good. But sometimes they're going to give us the symbols, so we got to be able to know how that works. So how about this one? A given not B. Let's do this one in blue. So what, do we see a row or do we see a column? What were we given? Not B. We give it another column, right? So we were given, it's always the second, that's the hardest, that was the hardest for me, is the second thing is the thing you have to focus on. We were given not B. So we know that this happened. These are the numbers we are going to use. We only got 3 of them. All the others we ignore. Okay, ignore everything else. And we want to know that A happened. Again, we could go through the formula. We could see it here. This is A. This is the intersection, A and not B. So I don't think I have it written. This would be A intersect not B divided by the number in not B divided by this. This is our total. So we get a 70 divided by 700, which is 0.1 or 10%. And again, we compared it to see if, did the ad really work? Well, those who saw the ad, 20% more, or 20% bought it. Only 10% who didn't see the ad bought it. So that ad must have affected 10% of the people who saw it, right? They got a 10% better. So we also use this to say that these are not independent events, right? The fact that they saw the ad was they were more likely to buy it. Okay, so we're going to also talk about independent. So far, so good? Okay, so know this stuff. And again, you could go back to the lecture. This was 8.5. This was our first section after test 2. So, but also, hopefully this brings back those things. Let's see, what's the next one? So here's, again, we could have used a Venn diagram as well, right? We got 2 things happening, A and B. We were given a situation where they were either in one of the, everybody was inside the circle, one of the circles, because they were all in the group. There was nobody outside. But, so this A part here would also be the part of A that had not B. This would be the part of A that had B, right? And this part over here would be the part that's in B but not in A. So we could actually use a Venn diagram. If you feel good about those, you could use a Venn diagram to sort of put the numbers in their place, and then we could have done the calculation that way as well. Okay, but just remembering totals. So this probability of B would be, both of these regions, and it would also be the probability of A in here, right? A and not A, B and not B. So you can use a Venn diagram. If you're visually oriented, that might be the way. A couple of these, that's when I was working through them. I used that because it was okay, easier for me to set it up. Others, when I gets to the symbols, the Venn diagram was actually harder for me. So, but again, I don't want to focus on methods. I want you to find a method that works. Don't worry about learning them all, but get one that works. Maybe stretch yourself a little bit, but we'll be okay. So we've got this formula. The probability of A given B is going to be the A intersect B divided by the probability of B. So we also looked at that. Now that was a little different. It wasn't the number, but if they give us probabilities, basically we could treat it the same way. Because remember that probability is always out of 100%. So we can I just treat percentages as if they were numbers. So if it's 40%, I say that's kind of the same thing as if there was 40 out of 100, right? So that means that even though these symbols are different, it's really not different. It's just a different way of counting. Percentages give us how many out of 100. So, which always is cool because what are we dividing by? Usually 100%, because we know B happened. So that's 100%. That's 100% of the things that happened when we go this route. Of course, it's not necessarily what we're given, but you can go with that. Okay, and then that also another version. Again, we don't have to memorize all because this just is some algebra. They multiplied both sides by B, right? And so they really just moved this over to the other side. And instead of doing division, they're going to give us a formula based on multiplication. Okay, so we could use either one of these. And again, if you remember one and can do the algebra, you've got both of them. But as you go through, what I encourage you to do is start making up a note sheet. Not that you can use it on the test. So, oh, if I can't use it, why should I make it? Because when you make it and you go through the problems, you're looking at that note sheet, you're working it, and it puts it in a place in your brain without you having to try to memorize things. You will remember it, not memorize. Memorize, I can't memorize anymore. I was talking to someone I used in like high school and my early college years, I had a photographic memory, literally. I could, if I read something, it was in here in my mind. When the test time came, I'd know, oh, that was on page 42, blah, blah, blah. And I couldn't always synthesize stuff, but I could remember exactly what page things came from. I've gotten older, I can't do that anymore, so I got to do some other things. But, what I found, have that visual so you can see, So do that, and see which one makes up. And as you work through it, the things you're not using, get them out of there because that's going to confuse you. And so if you can get it down where there's like only 3 or 4 things, hey, that's all the things I really need to remember. Everything else I either already remember or I'm not going to use. I'm not going to use all these different versions. I'm going to use this one. So just put that one there and see how you can make it. But as you practice, have it there. And then as you go through these, my suggestion is set it aside, give yourself enough time so you're not doing it right like Wednesday night before or Thursday afternoon before the test. Set it aside so you can give yourself like a day break and then come back and look at the review test, at least the highlighted ones. Take that at, it's 23 questions, so that's very close in size to the test. Take that as if it were the test. Don't use your notes. Maybe use your notes the first time and then but give yourself that 1 day break so you can kind of forget, right? But you'll remember some things, but you'll know what you're forgetting. And then that always tells you what you need to do, okay, what you need to maybe work a little bit more on. So as we go forward, if you can kind of plan out your schedule, okay, I'm going to study, I'm going to try to get everything done by this date. I'm going to take a break and not even do anything on the math for a day or 2. Then I'm going to go back and see if I can take this because I worked through it and I got them all. Now let's see if I can do it. And again, you'll have they're the same numbers, so it's not quite like taking the test, but it'll be similar. Okay, give you that experience. Okay, before we get into this, well, let's go ahead and this was another way was using a tree diagram, and it also leads us into the next section, which was binomial. The Bernoulli something, I think. It was a Bayes theorem. also leads us there. So when we had a conditional, remember we would always start with the non-conditional part. So they usually will give us the probability of either A or B. So we take the one that has no condition, we set this up, and then we can set up the probability of, say, if B had a 60% probability of happening, remember it would be a 40% of not happening. That's another important thing to remember. I know the probability of something happening, I know the probability of it not happening, because sometimes we've got to use the probability that it didn't happen, right? And then these are the conditionals. So this is the probability that A happened given that B happened, right? Because this is the branch where B happened. And this down here is the probability that A didn't happen given that B happened. So these are your conditional branches. And then at the end, that gives us the probability of the intersection. Okay, so if you do the tree diagram and really think of what each one is, that will also help. Remember, it can be confusing. I got it mixed up myself. I was, intersection, but what's an intersection and what's a conditional? Because they sound, when you read them in the word problem, they can sound very similar, right? So we got to kind of go back and look for that little clue. Is this an intersection or is it a conditional? Look for that word given. Oh, that's a conditional. Look for A and B, right? A and B, but intersection. Yeah, intersection is A and B. A and B happen, that's an intersection. So I kind of know where that's going to be on this tree diagram. And then the bottom's similar. It's probability that A happened given that not B happened and so forth. So another one's going to fill this in. I'm just going to see. And then again, it leads us to this. If they're independent, we can just multiply them because they don't affect each other. But rather than going any further, let's take a look. We're going to keep that. Let's take a look at a couple of the questions. Review highlighted. And let's close this up. Doesn't work, so we'll go here. Too far? No. There it is. Okay, so question one's a highlighted one. They give us some information. They give us the intersection of A and B, and they give us a probability of B. Then we're supposed to find the probability of A given B, right? Now, if we remember the formula, it's not too hard. You remember, oh, this is, remember, probability of B is the total. Again, and this is where it helps if you kind of label them. What is the probability of B? And this, since it was given, it happened. It's the total of what happened. And we want the probability of A, but we want, in the numerator, it's got to be B happened and A happened together. So read that intersection as an and. We know B happened and A happened along with B. They both happened together. So the probability of A intersect B. Okay, cool. 0.4 divided by 0.9, and that will give us our value. 4 divided by 0.9 is going to give us a 0.444 or a 44%. Notice it's more likely, but no, never mind. A given B was only 40% because B is only 90% of the whole stuff. Gives us overlap. And we also could have gone with a Venn diagram. Just label 1A, 1B, and we know that the numbers we're putting in here are probabilities. You could do them as percentages, and think of them as numbers. A intersect B is this middle piece here. That's going to be 0.4. Now be careful out here when we construct, if we want to do it, it's not 0.9. This total circle of B is 0.9, so this would be 0.5. And that might help you as we get to Bayes' theorem, because we end up adding some things, right? So the total for B is 0.9. That's what we divided by, but we're seeing how much that 0.4 is, and that might, and again, we didn't even have to see what was in A, because we were given a conditional B happened. We don't care about anything else. So we could use Venn diagrams to kind of set this up. We can use the formula, but if you use the formula, kind of think about what each of these means. Otherwise, it's just memorizing things, and it's easy to switch. We got A and B, but it's easy to switch them the wrong order, especially if you've got a little dyslexia or a lot like me. And this, A given B, and then pretty soon we're going to do B given A given this, and it's easy to get confused. Okay, but if you get the language that connects to it, we okay with that first one? Okay, that's a major one, getting down conditional probability. So second one, very similar. So that's why you had two. We're given this probability of A given B. We're also given the probability A given not B. And we're given the probability of B. And now we got to find the probability of A. How are we going to do this one? How are we going to do this one? Which method do you think would be the cleanest, the best? We're given two conditionals, right? Given B, this is how A happens. Given not B, that's how A happened. And we're given a non-conditional. We're given the probability B. Thinking back to what we just went over, what does that suggest? Right, because we're going to use a tree diagram, so we're going to do two multiplications. So the tree diagram just sets us up with what kind of multiplications we're going to do. Now, yes, we're going to take this one times this one, and this one times that one. But the reason we do, let's see, let's do it up here, is when we go for the tree diagram, remember we set it up with the non-conditional. We were just given B. So this is B, and this is not B. And we are told that B here is 0.4. And this is going to, so that makes this one have to be 0.6. Again, they didn't give it to us, but we can screen it out of there, right? So then remember, after we go off of the B, that's going to be a conditional. And we can get two branches off here. Either A is going to happen or A is not going to happen. That's A. That's not A. And what are we given? We're given the conditional, if B happened, then the probability of A is now 0.7. So this one is 0.7. And you can see that's the multiplication principle. We multiply along that. That gives us our intersection. Okay. We don't really care about not A happening because that's not what we're looking for. So part of it is, what are we looking for? We just need this, so we don't care about anything else. But down here we do care, because if B didn't happen, then A could either happen or not happen. So this is going to give us another one. Again, A, sorry, this is kind of, and not A. Didn't leave myself a lot of room. But this one, probably not B given, probably A given that not B happened, we've got that value, that's 0.5. Again, we could figure these out, right? Because if it's 0.5, then the other's 0.5. At the top is 0.7, the other's 0.3. So it's always this relationship that everything's got to add to 100%. So we could get it if we needed to, but these are the two. Once we get this and this, we add them together because they're two separate ways to get A, right? And again, it's just multiplication. So it's a 0.4 times 0.7 plus 0.6 times 0.5. And again, you could have, there's a formula that, this probability of A given B, blah, blah, so that multiplication one, if you remember that formula, maybe you went that route. You didn't have to draw the tree diagram. That's fine. Okay. And we can enter that one, 0.7 times 0.4 plus 0.6 times 0.5 is 0.58. And again, if you want to sort of reconstruct things, you could put everything else and make sure it's all working, right? Because everything has to add 100%. So 58% chance that A happens, a 48%, a 4% chance that B happens, and there's some overlap. Maybe there's, you could see what the other probabilities are and stuff, and but that should do it. And again, here, let's see. Oh, good. I'll carry these down. We'll check our answers because we do that, right? Always checking the back. Did we hit them right? Let's see. Number 1, 4/9, and if you put in 4/9, 4 divided by 9 is 0.444. On the exam, I'll take either one. I'm, WebAssign, they want one or the other, either decimals, and so they're kind of picky. If you've got a right answer, you will get it right. Okay, so either 44%, 0.44, 4/9. Number 2 is 0.58. That's what we got here. Okay, so we're doing good. Okay, so and I do encourage you as you're going through, check your answers. So because if you didn't get it right, you don't want to keep going with there's a misconception. You want to get misconceptions dealt with as soon as possible. That's the reason I still have that problem where I'm still making mistakes on some things because I didn't get that fixed. I went like a half a semester doing it the wrong way and then have to check it. And then you get that in there. Then finally you get it right before the test. So I got all right, but I still carry that wrong way of doing it because I did it so many times, right? So the sooner you can fix a misconception, why did I get that wrong? Oh, I mixed these two up. And then you'll be better and you'll practice with the right way of doing it. And that's what will hopefully dominate. But unlearning is actually harder than learning. I learned it. I got it. Oops, I got it backwards. Sometimes they're hard to unlearn. Okay, so far so good. Again, my goal today is not to work a lot of problems, work a few, but is to get you in this review process. Go back, pick out like the main things. These are the ways. And while I can do that for you and you can receive it somewhat passively, we've got a little interaction. If you go back and do it yourself, pulling it out, remembering it'll strengthen those dendrites and axions and electrical impulses in your brain that we call them, that is the way we think. Okay, so that's the first two. Yeah, let's see. Let's do 4 and 5. And then we'll call it good. Then we'll start off maybe with some base theorems. Some of these we won't necessarily work them all in class, but I will get, again, individual videos so that if you had a question like on 5, there'll be an individual video you can go back to, as well as what we're doing here. And I'll make it nice and give myself room so it's all there. Here, I'm just focusing on, I want you to start thinking how you need to think through things. Okay, good. Where are we? We're at 4. 2 distinguishable fair dice means one's red, one's green, or something. You can tell the difference. Yeah, here it is. Let A represent the event that the red die is a 2 or a 4. So that's event A. Got it, either 2 or 4. And then B is the sum of the 2 dice is 6. The red die is a 2 or 4. And then find the conditional probability of B given A. So What do we know? What happened? Rolling our dice, what do we know happened? Know anything about the green dice? Sort of, but not directly about the green dice. What do we know about the red dice? It is either a 2 or a 4. We know that. That's what this is telling us, the condition. We know it's a 2 or a 4. We know we got a 2 or a 4 on the red dice. So maybe draw a picture, 2 or 4 on the red. That's another thing is sometimes I found that I'm also very color, so if I write, in fact, that's how I got through math. I got a 3-color pen, so red, green, and black or blue or something. And so sometimes I'll do the red and red and the green, and it helps. Use a highlighter, whatever. You can bring as many different color pens or highlighters to the exam as you want. So we'll do that. Okay, so we know we got a red or a green. So that happened. Find the conditional product, but then we want, what does B need to be now? The green dice. I don't really have green, so I'll go with blue. So after doing that, what does the blue dice need to be? Or that's not the blue dice, the green, we'll call it. Well, if we got a 2, we need a 4 here because we need it to add to 6. And again, we don't know that happened, but that's what we're looking at probably. If we got the 4, then we need a 2. Okay, so it's kind of the reverse. So that's, okay. So, but it's a conditional. So how can we got these numbers. We know how many total different ways can we get the sum. That's going to be out of 36, right? But be careful when we're doing the red dice probabilities. How many different ways can we roll a 2? 1 out of 6, right? So when they're talking about an individual die, that's a out of 6 possible, but when they're talking about the sum of something, we got 2 dice, that's a 36. Okay. Could go with a Venn diagram. Could go with a tree diagram, because could we, right? We're given the conditional that A happened. Could we calculate the probability of B happening? Right? We need the non-conditional probability to start off with a tree diagram. Yeah, let B represent the event that the sum of the 2 dice is 6. Again, we don't care about whatever happened to the first one, so that we can get that probability. So we'll go with the tree diagram. Let me do it down here. And again, you might do it differently. You might go for formulas, which is fine, because we all do things a little bit differently. We remember things. So what would be the probability of B? Well, the probability is the sum of the 2 dice is 6. Now remember, this is where it's going to be helpful. We don't give it to you or anything, but all the probabilities, remember, how many different ways can we make a 6? Well, there's 2 with that given, but remember, right now we're just going to roll 2 dice. How many different ways? 5. It's subtract 1 from it. How many ways can you roll a 7? Subtract 1. There's 6 ways. Then to get a 6, there's 5 ways. To get a 5, there's 4 ways. And if you go the other way, an 8 is they mirror each other. So kind of look at that and just see it so that you don't have to redraw that whole chart. I mean, we could, and then we could count how many ways can I roll a 6. But that 7, and that's why in the craps game, 7 is the most likely roll when you're rolling 2 dice, actually. 6 is the next most likely. So it's going to be 5 ways out of how many did we say? Total of 36. So kind of play it that way. So we know the probability of B is, I guess we could do it with fractions, 5 out of 36. So we put that 5 out of 36. And so this is going to be 31 out of 36, right? So what are we trying to get? We're trying to get the probability of B given A. So A, let's see, given that A happened. Oh, I don't know if this is going to. I don't know if this is going to work. And again, the other thing I would like to tell you is this is not A, this is A up here. I try to come into class I didn't work this yet recently. So I'm trying to get you to think through things as much. And if I get stuck, now when I do the videos, I will work them in advance and have a smooth way, but I want you to be able to think, if my method didn't work, what do I do next? So given that we got B, could we find the conditional probability? Can we, okay, so now that we know that B happened, they add to 6. They add to 6. So let's see. Given that B happened, we got 6. So how are the different ways we could get 6? Well, we could do a 1 and a 5, 5 and a 1. We could do a 2 and a 4 and a 2. And we could do a 3 and a 3. Right? So those are all the ways we can get A to happen. Of these 1, 2, 3, 4, 5 different ways of getting a 6, that's B happening, how many of those would have the red dice be either a 2 or a 4? There's 2 ways, right? And I'll say the red one's the first one, so here's the 2 and here's the 4. But those 2 out of 5 is now that conditional probability. If B happened, we have a 2/5 chance of A happening. And remember, this is going to give us B intersect A. If we get B intersect A, we could then come back to the formula and divide by A, because remember this one, so maybe we use both. The probability B given A is also equal to the probability of the intersection of A intersect B over the probability of A. Okay, if I get this intersection, I could come back and just say, well, what's the probability of A happening? So that goes back to rolling a 2 or a 4 on a red die. Okay, so we'll do that next. But this intersection, the probability of the intersection, we just multiply these two. 5/36 times 2/5. Oh, cool. The 5's cancel. This is 2 out of 36, which could reduce down to 1 over, I don't know, 17 or something. But I'm going to leave it that way because I'm going to plug this in my calculator. I don't have to get reduced numbers each time of the way. And actually, I don't like to do it because 2 out of 36 is a lot more meaningful to me. Because I remember everything's out of 36. I'm going to use this one. And what is this? This is the probability of the intersection. So that's my numerator. And again, if you want to put it in as a decimal, you can. But for right now, I'll leave it this way. 2 out of 36. And then now we step back. Can we calculate just the probability of A happening? Yeah, we can. Probability of A happening, we get a 2 or a 4 just on the red die. So it's just like rolling the red die first, right? What's the probability of getting a 2 when we roll a red die? 1/6. What's the probability of getting a 4? 1/6. 2 or a 4, 2/6, right? So probability of A, we just do our counting, is 1/6 plus 1/6, which is 2/6. So we can go 2/6 here. And then with fractions, we've got 2 over 36. And we're going to flip the bottom and multiply, right? Because that's when you divide by a fraction, you invert and multiply. So 2/6 becomes 6 over 2. 2's will cancel. 6 divided by 36 is 1/6, right? That whole thing is 1/6. Okay, and that's the probability. So we know A happened at either a 2 or a 4, which was a 1/3 chance. If that happened, then we've got 2 chances. Makes sense. Let's see if we're right. I don't know that I'm right or not, but let's check. Again, if I'm not right, I got to go, oh, we'll do this next time, okay? But let's check it. That was question 4. Is it 1/6? But does my logic seem okay from what you, good. I always got to check because sometimes it's off, right? Let's see. Let's go down to the answers. And 4 is 1/6. Oh, I feel good. Okay, now take a break. Go get something to eat, get your comfort food because that feels good, right? And then it'll reinforce, hey, I did a good job. This is the way you got to prepare. So it is, we've got this whole week and we got all of most of next week, but do that kind of thing. Go back, but try to focus, don't try to learn everything again. And hopefully, if you haven't, if you got a lot of the homework to do, let's get on it. But also focus on these, focus on because this is going to focus you on exactly what we're using. Go back and do the things. And we'll do this. I'll keep making up the PowerPoint will kind of continue. I'll just kind of take the snippets of sort of the most important things. And if you'll kind of work through that and make your personal little note card. What I did is I did 4x6 little note cards because it's better than a piece of paper because it's a little bit harder. And again, I would just put on there. It's got 2 sides if you need it. And I'd get maybe a backup so that as I learn things, I can say, okay, that one I don't need on there anymore. Boom. Or this one, I'm not even using it. Boom, let's get that off of there. And then get it down to, oh, these are the things I kind of need. And you'll see by the time you get to the test, you won't need that card anymore. It'll all be somewhere that you'll know how to access it. Some of the things you might want to keep that there because it's good. Maybe, while I'm passing out exams, you're just looking. As soon as you get that exam, you write down those things. Right? That's how you can you do a memory dump. These are the things I still kind of struggle with because what's going to happen is you'll start taking the test. And even though you kind of had it, facts start getting confused as you go through. And then at least that's what happens to me, So if you can kind of bring in the things that I always think I know it. And then I get going something and then but I forget it or I mix it up. Write it down and then you've got that to go back to because you're coming in with a fresh mind. As soon as you start working questions, your mind gets a little bit scrambled. You're doing different things and it's harder to go back to that fresh mind state. But if you write down some notes first thing, that'll help you. Okay. And remember to breathe. I play the Native American flute. And sometimes when I'm nervous, though, I forget to breathe. And it's like, I'm going to pass out. Oh, just breathe, because you're so busy doing what you're I'd like to play the bagpipes. I've never learned. I think that would be a hard one because you're filling up the bag. But when you're taking a test, remember, breathe. Take your little breaks to breathe because the more oxygen your brain gets, the better it works as well. And when we get tense, we tend to have shallow breathing. We're not getting as much oxygen to our body. Our brain's not working at its full capacity. So those are having success in school is more than just getting the facts. It's how we learn to process it. And that's why you're here. You're learning how you work. How does my mind and body work together? You will find your individual ways through and you'll get the success. Okay. So we'll keep doing this. Wednesday, we'll do a little bit more review and we'll make sure that Friday's just kind of like an open day. You can come ask any questions you want. And we'll get some videos posted as well with sort of more of a smoother way of going through. All good? All right. Thank you, guys.